All right, you guys. So we're going to go over all of the problems from from the Unit 2 quiz. And yeah, I'm just going to go through all of them and talk about my thinking and see if you can figure out what you were missing if you were doing some thinking about it. So this very first problem shows figures 1, 2, and 3, and we need to figure out what figures 0 and 4 look like. So if I look carefully, the difference between figure 1 and figure 2, it appears to just be these tiles right here. So if I just look at those as being the new ones, it starts to become obvious. I start to see, okay, it's these 3 new here. I see my old form there. I see that there's 3 new here. Here are the 3 new ones. So I can see I'm always sort of adding this little extra L shape. So if you were to, I'm going to cheat a little bit here because I know I have a tool that you didn't have on your quiz. But if you were to draw figure 4, you would just basically be showing this exact same, the exact same figure, and you would just want to add to it one little extra group of 3. So instead of these being my new tiles here, let's see, it won't let me draw that anymore. Sorry, my new tiles would be another little L shape like this. So that's what your figure 4 should look like. Your figure 4 should have just added these tiles here. And then if I look the other way, if I know that I'm adding a little L shape each time, getting bigger and bigger, well then I should be able to go backwards and erase the old ones. And when I erase 1, it looks like figure 3. Taking away 2 looks like figure 2. So when I go here, I see that they are, I see that it is sort of getting smaller in this direction where I'm drawing these arrows. So that means that in this one, sort of this little L shape right here is going to be, these would have been the new tiles in this figure. And so those need to go away, and when they go away, what I'm left with is this little figure right here. So if I were to just copy that one and paste it over here, that is what my figure 0 should look like. Some people showed a different orientation for their tiles here, but if you did that, I probably circled it because some people showed the 3 tiles getting added in a different way. But it is important to recognize that it was always in an L shape, and so if your pattern continues, it should continue to be in that L shape. So drawing the figures, so what we just did was we just drew figures 0 and 4 above. The next question says, how many tiles will figure 13 have? And we need to show our answer here. The way I started this was actually to look at, there are lots of ways to do this. Some people use tables. Some people tried to do some proportional math here, but if you'll notice, these numbers are not proportional, and so that was an assumption that you would have gotten wrong. The way I recommend to do it, I think the simplest way to do it is to use the rule. I know that the rule is y has to be y equals mx plus b of some type. And when I look at this, I see that the starting value, I know that b is always the starting value. So my starting value is always the number of tiles in figure 0. So that will be 4. And the other thing that I care about is the m, which is the number of tiles that we add each time. So that would be, we're always adding 3. So this should be 3. This should be 3. And so my rule should be y equals mx plus b. So it should be y equals 3x plus 4 in this case. The last part of this is that I want to just say that a lot of students got this part right. Oops, they got C correctly, but they still missed B. If you were to use the rule to solve this, then what you would do is you would say, well, y, which is the tiles, should equal 3x plus 4, and I know that 3 is the number of tiles it is adding each time, right? Which means each new figure number. So that means 3 times the figure number. So each figure number, we're adding 3. So if I wanted to know, so basically what that means is that these figure numbers here, this is what we're talking about when we're talking about x. So if I was going to do figure 13, I would just plug that information in. I would say, well, I know that the tiles are equal to 3 times whatever the figure number is. So in this case, the figure number is, oops, sorry, I wrote the wrong number, is 13. And then we add 4. So we should be doing the math 13 times 3, which is 39, plus 4. So we know that tiles are equal to 43. There were other ways to solve this. A lot of students did a table, and they would just draw the table out, and that would have been just fine. Some students drew out the entire table. Some students started at figure 0. If we knew the x for the tiles, or x for the figure number and y for the tiles. They said figure 0 had 4, figure 1 had 7, figure 2 had 10, figure 3 had 13, and then these students would say, well, I just kept adding 3 each time, and then sometimes they would get this correct, and sometimes they would miss something because they did some math wrong here. So if we were to continue this, let's see, I should make this smaller. If we continue this the entire time, then we would get, all right, 4 would be 16, and 5 would be 19, and 6 would be 22. And if we kept drawing our 7, 8, 9, 10, 11, 12, 13. If I kept drawing my table, I would do 7, which is plus 3 more, which is 25. 8 is 28. 9 is 31. 10 is 34. 11 is 37. 12 would be 38 and, or sorry, 39. Sorry, 12 would be 40, and 13 would be 43. So if I fill those in, it would be counting by 3 each time: 22, 28, 31, 34, 37, 40, and 43. But a lot of students would use logic where they would say things like, well, I know that 1, they would just do things that were not quite right. Some students would say things like 1, I know that figure 1 has 7 tiles, and so they would say, if I multiply this by 13, I should multiply this by 13. But that doesn't work. As you can see, 7 times 13 is not 43. This is not a proportional relationship, so we cannot just multiply those. That logic does not work. And you can test that logic by using the information that you do have, right? What's given to us already are figures 1 through 3, and we can do a test here. We can say, well, is that true, right? Is figure 1, I know figure 1 times 3 would be figure 3. Is 7 times 3 13? And the answer is no, right? I can't, when I multiply by 7 times 13, or 7 times 3 is 21, and that is not the result that we see in the given pattern here. So you can't use this proportional relationship. It does not work, so don't use that. But if you did fill out a table where you were just remembering to add by 3 every time, that would work.